why I think this stuff is interesting. I think for my work, or the kind of stuff that I've been working on, I think ludics is sort of something that is required to take into account, or of like traditionally, like what Sellers proposed, a kind of an active computationalism, like this idea that like maybe the mind has a computational structure, but it's also a requirement that is embodied to be able to give rise to intelligence. Can you move one, John, please, to the next one?
I think Gabriel is here. Maybe he could just make you a host and you can
yeah. Yeah,
Gabriel?
that's also fine.
Yeah, I can do it. Sorry, guys.
No props.
No worries.
I thought that John could solve that for me, but I think co-hosts don't have that privilege.
I just unshared, so yeah.
Did it work?
Am I the thing? No?
Yeah.
Oh, yeah.
You're the thing now.
Yeah, cool. No, let me just...
Gabriel, are you recording, or should I keep going?
I'm recording as well. If you want to stop, it's okay, but it's your call.
Okay. I'm going to go ahead and stop because it's on my computer.
Sure.
I'm just trying to get a sense of, like, okay. Do you see my one screen? The right one, I hope?
Yeah.
Actually,
okay,
yeah.
cool. I see it. I see it in
live,
the...
But there's also, the menu. We see this, yeah. Actually, yeah.
What do you mean?
I mean, we see more than we ought to see. Like we see the contents. Yeah, now it's better.
Cool. Yeah. Okay. So the idea to sort of give a little bit of context to this comes from trying to reconcile the idea of Sellers and what he thinks is important about reason in a kind of framework which sort of reconciles his more like enactive insights with his more like computational insights. The computational insights being his sort of the idea of the game of giving and asking for reasons, right? So, oh fuck, what the fuck? There's something really weird happening with my trackpad, but it's fine. I can't use it like this, sorry. Oh, wait, just, why? Yeah, something really weird is happening with my computer, but it's fine. I'll just get something else. Just a second, guys. So I'll just keep going. So like Sellers is both a normativist and a naturalist, and he indexes the possibility of agents having reason in their capability of tracking what's happening on the outside world and linking it with what's happening in their inner minds. Sorry guys, just a second. Let me get my things because I can't have access to them while I'm sharing my screen. So like there's this kind of reason, and we hinted the sort of reading that we've talked about it before, which is to sort of put Sellers in the context of a transcendental philosophy. But I think that what ludics provides is sort of like this idea of like following Carnap in considering that it's not so much that the normative structure of thought comes not so much from the transcendental psychology of the subject, but rather from the logical structure of language. And I think that the sort of whole program of game semantics, dialogical logic, and ludics sort of give like a good, like sort of manifest that insight in very proper formal terms, even though it's not really like this project is not really finished. Like at this point, like not like Girard is not working on ludics anymore. He moved on to something called transcendental syntax, which I'm still like trying to get a sense of. So like the idea being that for the work that I do, at least there's this sort of assumption that what expands the computational capacities of corporified agents is the process of externalizing their thoughts into the material world, which gives like a nice flow from language into technology, or for technology into language into mind. And I think that by sort of thinking about language in the context that it's as an activity which is an extension of this process of externalization, you get like a good intuition for the fact that maybe it doesn't matter that the brain doesn't really have an internal computational structure, but that the computational structure can be something that comes much more from the pragmatic instantiation of these external resources rather than from internal constitution. So this kind of gives like us an ability to reconnect an activism and computationalism in a way that it wasn't really ever thought to be possible, simply because well, there's like a really long story in making inactive anti-computational, and this is something that I'm also quite interested in, more just to sort of give like to figure out whether one it's excludes the other, but at this point it is not really like compiled in any sort of writing or thing that I can present. So but I think that like ludics really gives like a really good structure to think about these things as being the result of a process, and therefore connected to what we've been talking about over a few of the last meetings, which is, you know, the game of giving and asking for reasons, inferentialism, and so on and so forth, and also giving like quite a nice intuition onto how the modeling capabilities that applied mathematicians display are where like how language users are able to reappropriate these strategies that Mark Wilson was talking about, and that we'll come back to in the course of the next meetings. Also, just like a little disclaimer is that like I'm not really a logician in any sense of the word, I guess. So if you guys see something that doesn't make sense or don't understand anything, let's try to like really stick to it. Although I think that like the formal stuff is not really like super important for today. I think it's more like there's a kind of more like a history of it. Like I kind of see this as a non-technical introduction to this to these things, because yeah, like even, you know, reading like Reza's like the computation as interaction or interaction as computation in his book, like you can sort of see that like to get really formal with this stuff, it requires like a lifetime of engagement. It's really complicated things. There's stuff that like I don't really get yet, I think, especially in relations to what some of the properties of ludics, but I think that it will be nice to sort of like waddle a bit in not understanding this with you guys. So let's begin. So the development, like, so I'll just give like a kind of quick overview of the structure. Is that like historically, like I was gonna say Sellers, but Jean-Yves Girard invented linear logic towards the end of the 80s, and it's like a kind of, it's a logic that is able to incorporate intuitionistic logic and classical logic into a kind of singular unified picture. Game semantics and dialogical logics are things that happened like way earlier. It's like stuff from like more or less the 60s. Like the reason that I'm gonna present the sort of rationale of Girard's engagement with linear logic and what he found it wanting and therefore became the sort of like starting point to develop ludics is sort of the reason why I'm putting why I'm sort of inverting and presenting the sort of like developments of linear logic first, and then game semantics, and then we'll get to ludics. But I just want to say this because I think that the sort of what is really important about game semantics and Japaridz's approach, which is like a different thing, but sort of very similar. It's the way that it sort of gives a kind of structure for linear logic to become to sort of like synthesize on one hand linear logic and on the other hand game semantics into what ludics is, which is basically a synthesis of these two sort of like proof theoretical, or I mean like proof theoretical frameworks. So like Girard kind of establishes this idea of the blind spot of logic, which is, you know, and then he sort of like ascribes from coming from the idea of soundness. So he says that a logic is deemed sound if and only if the proofs permitted by its syntactical rules preserve truth. That is, that the conclusion of a proof will not be false unless one or more of its premises is false. So he attributes that the question of logic soundness, he attributes the answer of this to Tarski, and says that after Tarski we framed the question of logic soundness in terms of truth preservation, but that so let me move to, so the conclusion of a proof will not be false unless one or more of its premises is false. So, and this comes from, you know, this sort of like formal arrangement. So what this means is that soundness, it's sorry, I can't see my thing. Let me just change it here. No, I can't. Never mind. So there's a kind of wait. So there's a kind of always the requirement of logic to have this sort of like upper level, which is the meta level, and it's related to the object language, which is this first slide, to sort of say what like and means and what A is, and so on and so forth. So we need, like, in order for this to make any sense, we need to establish a meta language which is separated from the object language, which is, you know, these symbols and these conventions, which is in a different strata. It's like on a higher level. So in this meta language, we can state that soundness, that we can say that the syntax is sound if the probability of X implies the truth of X in all models. So if X is provable, it's because X can be constructed by means of the syntactical rules of this logic. So this idea is to show that if we can change the syntactic relation proofs for the semantic relation entails, we obtain a set of formula in the meta language, which follow from the conditions by which the meta language gives truth values to the sentences in the object language, right? So for Girard, this is the blind spot of logic, right? Like the necessity of this recursive higher level that gives, you know, meaning to the lower level that itself requires a kind of higher level, and so on and so forth. So this is the kind of thing that Girard is trying to tackle in his work at that point in time, at least. So if the truth of I'll just go back to this, which is like a little bit more informative. So if the truth analysis of A can't say anything more than A, this kind of suggests that, at least for him, like I don't want to get into this sort of like more foundational question of the foundations of logic or whatever, but in his argument, like to say that, you know, A and B is true doesn't really say anything about A. So for him, it suggests that the truth of A doesn't really make sense. It's just like the constant repetition of A. But on the other hand, like the syntactical properties of A or the conditions where we can get a proof of A, it's not really trivial in the sense that he says that the truth of A is trivial, right? So that also already establishes this sort of like idea of that it's really important for ludics, that it's also like somewhat important for game semantics, or that is like already a kind of insight that comes from game semantics, I would think. Although he doesn't really talk about it in these terms, but it's the idea that like to understand, like we understand the negation of A in terms of a branch in a proof tree of A, right? Like not A is any result of looking for a proof of A that it's not A. It doesn't really matter what it means, right? Like it just matters that it has a kind of structure of all the moves that we can have, or the moves that we make in order to figure out what A is or to prove A. So he says that his fantasy for mathematics is to reduce everything to, or actually he says something very different, right? Like he says that like recognizing this blind spot, you can get like two different responses. One is what he says that it's a essentialist response, which to sort of question the necessity of a meta level to justify logic, is something that would point to logical intuitions or to a kind of transcendental logical structure in logic itself. And the other one, which is what he says that he takes, although we always ever think of ourselves as doing sort of like, you know, the right work or whatever. But he says that the other one is a kind of it is a kind of request for explication. He sees that as having to have, like, how does this process work? Like, how can we get some sort of like structure from this that would allows us to posit what A is, right? Or to say that like maybe we don't really know what A is, but we have a kind of interpretation of like how do we get to A through a series of moves, right? So I'll just give like a brief, I'll try to make it brief, but it's a kind of brief introduction to what he uses to sort of like construct linear logic. And he starts with the sequent calculus, which is, you know, a formalism that a lot of systems use, like a lot of classical predicate logic systems use. The basic unit is the sequent, and it's composed of two sets of formulae, which are on either side of the turnstile, which is like the little thing in the middle, which says proofs, which should be read as proofs, right? Like the left hand side of the sequence, so A, B, and C express a conjunction of the premises of the proof relation, and the right side expresses a disjunction of consequences following from this premises. So we read like A, B, C proofs D or E or F, right? So we know that that the right side of a sequence expresses a conjunction of terms, while the left expresses their disjunction, right? So, but we also know, because of the De Morgan transformations, that conjunction and disjunction are dual to each other. So what is sufficient to negate like when you negate a conjunction, you turn it into a disjunction, and vice versa. So anything that happens on the left-hand side of a sequence can be shifted onto the right side by replacing it with its negation. So there's these operations reveal to us something which is like sort of the essence of negation. So instead of thinking in terms of like not A is true, and that meaning A is not true, this allows us to think of negation as the exchanging of premise and conclusion, of input and output, of left and right in the sequence calculus. So I'll just show all the rules, and then we can go back and sort of talk about them individually. But this is fucked because I couldn't really change I didn't know how to change the screen's size in text, which is really dumb, I guess. But I'll get to it eventually. So these are the sort of these are the rules of the sequence calculus that Girard is using. So these rules are divided into two major groups, which are the logical and the structural ones. Oh, sorry, which is these ones. And each of the logical rules introduces a new logical formula on the left or on the right of the turnstile, which is what we read as proofs. On the other hand, the structural rules operate on the structure of the sequence and ignore the shape of the formula. The two exceptions of this this scheme is the sort of like the first two rules, which is the identity rule and the rule of cut elimination. The rule, let me get the L1. So the L1 rule states that whenever one can prove that delta can be concluded from some sequence of formula that contain A, then one can also conclude delta from the assumption that A and B holds, right? That this is true. The rule not R states that if gamma and A are sufficient to conclude delta, then from gamma alone you can either conclude that you can also get that delta or A should be false, so that not A holds. So all of these rules can be interpreted in these different ways. So instead of seeing these rules as descriptions for what we can get from predicate logic, we can also see them as sort of instructions for constructing a proof for a given statement. So in this case, the rules can be read bottom up. So the rule and R reads to prove that A and B follow from the assumptions gamma and sigma, we can prove it's sufficient to prove that A can be concluded from gamma and B can be concluded from sigma. So this also shows how proof theory can be seen as operating on proofs in a combinatorial way. So if you get both proofs for A and B, you can construct a proof for A and B, right? So these are the inverse of the rules of the sequent calculus, which is sort of like the how to say it, like the intuition that the Morgan transformations give us, right? Like that, you know, these two, these rules and the sequent rules are logically equivalent, and that sort of means that the reason that they're equivalent is because they obey this law of transformation that we talked about it before, right? Like that being on the left side, that what is a conjunction on the left side becomes a disjunction on the right, right? So that this is these rules are sort of what we call the contraction and the weakening rules. So the idea, so like this sort of opens what he sort of understands is that this opens another possibility of understanding soundness, not so much in the sense of thinking that the soundness of a logic tells you something about how it works, or tells it something about like it's how the structure that it's in place in each of these transformations gives you like information about what he'll eventually say that it's the geometric structure of a proof, right? So like a kind of, you know, instead of thinking about soundness as being like of being truth, that's not which the thing is. So this notion of soundness should be formulated into not being the sort of consistency of it, but in what it says about the structure. And so the other thing that he thinks is really important for this is not only the weakening and contraction rules, but also the cut elimination, right? So if he can establish that that any proof in the sequent calculus can be so I'll just go ahead to sort of explain this a little bit more, is that like the sort of like the idea of linear logic is that it suspends both the ideas of weakening and contraction, and also the idea of cut elimination. So the way the sort of reasoning for which he says that for the reasoning for suspending the cut elimination is that you can make is to say that any proof in sequent calculus can be made analytic, which is to sort of cut like an analytic proof. It's a proof which uses the subformula property, which says that all the information contained in the conclusion can be found on the premises of the proof. So in term, like, to be an analytic proof, this already implies soundness. So he sort of brings in the idea that to demonstrate that any proof in the classic sequent calculus can be rendered analytic is to sort of like repair its blind spots, so to speak, so that once that he can like show that these rules can be suspended and that you can still perform these operations without the rules themselves, this will be a sound logic. So I'll just go quickly through this. So this is the rule of cut elimination that says for any system, any sequent that is provable using the rule can be proved without use of this rule. So this is the cut elimination theorem. Also for a sequent calculus that have only one formula in the right hand side, the cut rule means that you can take, you know, this Greek letter that proves A, delta and A proves B. So you get, I don't remember what the first one is, but the second one is delta. So it says that every formula that can be derived using the rule, it's already derivable without the rule. So in a sense is redundant. So this is something that Paul Lorenzen, which is the guy that invented dialogical logic, which is sisters or like a kind of different game semantics, introduces. So this is his sort of insight that you can preclude from cut elimination in a logic, and that this would render these blind spots more visible. So the first line of a sequent proof, it's always given by the axiom rule, and so it's A proves A, or in this case, proves not A. So the sequent on any line, the sequent presented on any line below the uppermost line of a proof. So that's so if you call it, so in the top one, the cut one. So for instance, in the first one, you have proofs delta proofs. What is the name of this again? Is it this gamma? Yeah, it's gamma,
I think you
right?
can call it gamma, yeah.
Yeah, it's gamma. Yeah, so if you have it proofs gamma and A, since this is not the top line, it should come from elsewhere, which is not a rule of the calculus, because the one that doesn't have anything on the top, it's produced by one of the rules. So if we only know this, what can we say about the premises that are on top of it? So we know that the cut elimination was not used to produce this line, and we know that the line above proves that gamma and delta, it's composed of simpler formula than what is in this line. So we also know that this is sort of composed of subformulas of gamma and delta, and we know this just by inspecting the rules of sequent calculus. So analyticity can be established for any proof if you can prove the cut elimination is something that we can preclude. So a proof without cuts, it's a proof that does away with what traditional axiomatic treatment of logic uses as the sole rule of inference, which is modus ponens, which is if P then Q, P therefore Q. And the Curry-Howard correspondence relates modus ponens to function application, right? So if f is a function of type P, then Q, and you have Q as a morphism, and X is a type P, then f of X is of type Q, if that makes sense. So, but for Girard, the cut elimination is sort of a return to what he calls this meta level language recursion, which is something that you don't want to have, right? Like you don't want to resort to any of these exits from the mere structure of the logic. Like this is his like end goal thing. Like this is the thing that he wants to achieve, right? So what enables us to have cut elimination in the first place is the two rules of weakening and contraction. So the weakening allows us to repeat a formula at any point at like when they're inside the sequence, And the second one allows us to discard repetitions whenever we need. So to sort of like to come up with to sort of develop linear logic, the first part is to suspend these two rules, and the second part is to suspend the cut rule itself. So from knowing the Curry-Howard isomorphism, we know that we can transform any proof of the sequent calculus into a sort of a functional program, which is written in lambda calculus. So in the lambda calculus, the process of cut elimination maps onto the process of lambda term normalization, which is, you know, the process by which any of the nested functions can be reduced to its simplest form, if there is a form. But from this insight from lambda calculus, he kind of introduces a term where normalization is it's always possible. So the idea is that by getting this insight from lambda calculus, he makes a logic in which you can always normalize it. So these are the rules of linear logic. So through suspending the weakening, contraction, and cut rules, he arrives at what he calls the substrate of logic, which to him is sort of it's like finally getting to the essence of logic. Although he doesn't really use this, he says that this is the substrate of logic. So without the rule of contraction and weakening, these formula lose their eternal character, because they're now like they get consumed. So that's why like linear logic is used as a kind of logic of resources. It's not that it's explicitly designed to be a logic of resource, but it's that in the absence of the rules of weakening and contraction, like the specific formulas get get consumed when they're put in conjunction to one another. So yeah, this is sort of like you lose the capacity for infinite repetition. So like with like you don't have the linear implication here, because it's sort of using sequent calculus as a kind of basis. But like from if you have premises A and linear implication B and A, and you can also infer B from the premises, but in doing so you destroy both A, and A linear implicates B. So the conjunction it's split into multiplicative conjunction and additive conjunction, and multiplicative disjunction and additive disjunction. And he supplements this with two modal operators, which he calls exponentials, which is the next one, which allows us to replicate or discard a formula when needed. So this sort of like by introducing these operators, he sort of reconstructs like cut elimination. He reconstructs like the laws of weakening, contraction, and cut elimination with an operator, instead of this being a kind of structural feature of the logic. So it allows him to both model like classical and intuitionistic logic within linear logic. So in a proof where all formula are exponentialized, which is the ones where it has which is the sort of, because there's something it's not really super important, but it's missing the oh no, it's here, of course. The formulas that are exponentialized are the ones with the question mark and with the exclamation mark. So these are the classical proofs. And so the multiplicative and additive variants of the classical connectives collects back into their classical counterparts once the formula in which they occur are exponentialized. So this is a kind of way of thinking of classical logic as a kind of substructure of linear logic, and not the other way around as it's usually presented. But so like what Gerard is trying to get with this is that he's hoping to sort of reveal the blind spot of logic. But in the text that he writes about this, he says that he can't. He like that flattening the sort of recursive structure of logic. It's not enough to make the blind spot visible, but it's something. But it's a kind of starting point, and it's sort of like kind of getting at this endpoint that you need to sort of like to maintain soundness in the context of logics. You need to sort of recuperate this structure. Is something that he sees like not as a kind of not as a kind of failure, but a kind of acknowledgement that he's in the right direction. It's just that like he can't do it in the framework of logic. Is everyone all right? Like now that I have no faces, I can't tell. But yeah, if you want to say something, just say it.
What are the main Girard texts that you're basing this is getting pulled from?
I can give you like a good like I can give you a list of his, but there's like locus solus. There's the introduction to there's two texts. There's one called just linear logic, which is the one that he introduces linear logic. The second one is light linear logic, which is like from like maybe a couple of years later. There's also like the thing with linear logic is that a bunch of people make game semantics for it and make like continue to update and to sort of expand linear logic in ways that he's not really interested anymore. And when he gets to ludics, he's sort of like not interested in it anymore. But there's like a good few PDFs that I can give you guys later if you're interested. So to sort of like give, yep.
So I was going to ask you, can you restate the blind spot again? Just I'm kind of tired. I want to. Can you go back to that slide where there was the blind?
Sorry. So this one, you mean?
Yeah. Necessary versus source to an upper meta level, not justify the lower level.
He's talking about the distinction between the meta language and the object language, right? Like that every logic requires a meta language and then he sort of makes a joke that to justify the meta language, you need like a meta language, so on and so forth, in a way that you never have any sort of way of understanding why is this justified in proving things or requiring that like we can give truth conditions, right?
Yeah. Actually, the blind spot is the fact that there's an infinite regress, and you don't arrive. You can't really arrive at the end of analysis, so to speak. Like you can't really.
Yeah, exactly.
Yeah, something like that. Like this is why, for instance, Wittgenstein had to postulate atomic objects in order to have an end to analysis. Like you have like this super simple level that nobody understands really what it is about.
Yeah.
But it gives reference to all the other manipulations that he has in his logic. Yeah.
But also this that you just mentioned is also like a good intuition for why like for a very basic critique of inferentialism, which is like, okay, but like how, like to use terms in a web of inferential meanings, we would have to know the meaning of every term beforehand, right? That like there would be no way of positing a language that we can use without having already created it, just so to speak, right? Like there's a kind of like it is an appeal to this infinite regress, but what is, you know, what ludics eventually tries to come up with, but also all of these other developments give like a kind of credence to, is this idea of like not having to have the full extent of the rules to participate in the game, so to speak. So that, but the rules are progressively constructed as the game develops, right? Like that's the sort of like
Yeah, but this was already the informal argument by sellers, right? That you don't really need to know all the inferences that holds between any two terms of a language, because what you need, I think it is quite interesting because it leads to an account of language acquiring, like to acquire a language is not to acquire piecemeal elements of the language. It's not like that. You need to have already kind of a whole, like kind of a rule obeying whole in a sense, but it's not, this whole is not the whole of language. It's not language as such. Like it is actually like a certain set of concepts that holds one between the other, and then you can generalize and algorithmically elaborate to branch out to other concepts, right? So this was already, at least informally, it was already Sellers' argument.
But
right?
I think that what I think that what is interesting about this, like I understand what you mean, and I think that it's already present, but I think that this gives both like a kind of computational intuition for this, of like, why is this compatible with computation in general, but also it gives like how one can infer general rules about language from making like let's say like saying that like the sky is blue, like when you formulate sky is blue as a strategy of proving that the sky is blue, like you understand what it means to prove that what you're looking at is correspondent to what you see, right? And this allows you to sort of like expand, and this is, I think it's like the sort of interesting insight that I get from Mark Wilson, is that like once you have like particular strategies for asserting things in a given language, this allows you also to extract other strategies for asserting other things in the same language without having to know like the full extent of the language, right? And I think that this is sort of the really interesting thing about the ludics thing is, or you know, whatever form it takes, but is that it gives you some sort of like empirical intuition of like how this behaves in the wild, so to speak.
But just because I'm new to this, and I tried to understand ludics before, and the problem that I had is that like sometimes it's a bit confusing for me if he's worried about a problem in the philosophy of logic, like infinite regress. How does that get in the way of people actually using like logical systems? Like how is this a logical problem? And I think it gets in the way for me of understanding what is he trying to render more explicit. Like it seems like there's something he wants to open, a certain black box, something that is, let's say, a condition for a bunch of operators to be valid, and he's trying to open that black box. But I mean, from what I read, it's not really discussed in terms of language acquiring, concept acquisition.
No. So I think ludics is definitely not. I think that his move to transcendental syntax is what gives a lot of credence to this, because like it's not Girard that uses ludics as mapping to natural language. It's like a bunch of his students, like people like Quattrini and Alain Leconte and these guys. But he takes ludics and he brings it into like transcendental syntax to bring exactly this sort of like Kantian point of the like transcendental psychology and follow and rule following or inferences through rules as the sort of constitutive thing of thought. So he makes this link, but in the future, let's say, relative to ludics. But at the same time, I think that his question, I think that the thing with the blind spot is that like he sees, or the way that I understand it, or the way that he kind of mocks Tarski in a bunch of these texts, is that like he's saying that like basically you're only always like by accepting this division between meta language and object language, like you get something that is of course useful, but also meaningless in a certain sense of like we are unable to sort of like account for like how does this come about, or more or less, right? Like he wants to give it, he wants to and he says this in and it's like it's very difficult to understand because he talks about this as anti-realism in logic, and I don't really understand what he means, but he makes this sort of like weird salad argument. But that basically he's saying that like he wants an immanent logic. That's what
from
he
what
wants.
I understand is that, I mean, you presented it is already weird, like to call it sound and not true or not consistent, to define like the non-contradictory aspect of a logical system, right? I mean, it seems like he has a very, he thinks the Tarskian definition of truth is so weak, you wouldn't want to call that true. Like it's too weak to merit that name. And then there are stronger conditions that are not included in this sort of system derivation of propositions, which he wants to make explicit so that something can actually be called true. Is that?
Well, but like not in terms of, because I don't think that this was like fully formalized in linear logic, but later in ludics, he starts talking about these structures as not being like what is true, but what is provable, right? Mm-hmm. Like, and then I think that this also kind of moves for a transcendental to an immanentist view of logic, right? That he's like no longer concerned with these terms, right? Like he's much more concerned of like being able to account for the construction of provability, like of proofs. Like literally, he takes this idea from proof theory and sort of like inflates or deflates or whatever. Like for everyone has like a different meaning, but I guess that he wants to deflate through into provability, and he sees that as the sort of move into immanentizing logic. But I think that for him, this only comes in later in ludics and not through linear logic, because I think that with linear logic, he's trying to really get like a sense of like controlling all the different, like of uniting, let's say, all the paradigms of logic into a singular one. Although he doesn't really have this. Like it's really interesting if we think about it, because I think that he could make like a really nice case for like a kind of immanentist foundation of logic with his work, but he never really wants to do this, or he never gets to a point where he says like, okay, like it works. So I also see he's sort of like moving from thing to thing, and I realized only recently that like he still writes a lot about transcendental syntax. Like he's been releasing like almost like yearly new stuff in transcendental syntax. So it's not like he doesn't really care about this stuff anymore. Is that he just like really embraced the more like, let's say, philosophical aspect of it, rather than he's not so much interested in the like theoretical computer science side of things, which is where he positions himself most of the time. He's not really addressing like logic as such, or the field of logic. He has much more resonance with the people in theoretical computer science. So he's like slowly moves away from these concerns and moves into a more like what constitutes thought, like what constitutes rules. But this is already present in all of this, which I think it's like the interesting bit of it for like what me and JP and have been thinking about. I think that it gives like a kind of very very grounded intuition for like how to formalize it, how to incorporate it in like how to think about it in computational terms, and also like how to have there's like something that I couldn't really get to just because of like how immense the subject is, but there's like on John Baez's paper of like physics, computation, algebra, and something else, he gives like a really nice overview of like mapping linear logic to categorical structure. So it's sort of like linear logic is like the sort of like massive contribution that he doesn't really care anymore, and that like the only people that care about are like other people now. So that's also like quite funny.
No,
and how this sort of
I just wanted to understand a bit the mode. Like it wasn't clear to me that I understand now that I was getting it the wrong way, but it wasn't clear to me how this focus on proof nets and provability was like bringing something up that was like a blind spot, like the connection between a blind spot for logic, model theory, or whatever, and this thing becoming more explicit and included into the formalism. That part wasn't very key. But I think it's early on as well. I mean, I don't want to. I know it's not what I was thinking.
No, for sure. But I think that's also the thing of like presenting it more as a kind of like as the historical arc of it, because I think that like, for instance, like the thing that gets, like for Reza's book, what is interesting is like game semantics and Japaridze, which is like a slightly different take, I guess. It's like, because he really grounds, although Girard has a few papers about the geometry of interaction, like the theory of interaction as computation or computation as interaction, I can never really remember. It's really something that like Japaridze created, and then he creates his own logic with it, which is computability logic, which is like if I remember correctly, it's very much related to linear logic, but it's like not at all like ludics. So there's this sort of like really like it's a story with a lot of like different overlaps, right? Like I think that this is also something that I wanted to get at, because like it's also like quite weird to say that like, oh yeah, like I'm interested in ludics, but like the guy that invented ludics doesn't really care about it anymore.
Mm-hmm.
So because he moved on to something else. And I think that there's also but I think that to the thing that you're saying, I think that just his notion of like the blind spot it's precisely that, right? Like you can never get it, like you can't get truth through the formalism, right? Like you can only ever get provability, or if you claim that you're getting at truth, like you're recurring to an upper level that says that like what that system proves is truth, or something like this. I think that this is something that will for sure come up soon. But yeah.
He keeps the predicate true, or is he replacing it with provability?
No, he states it pretty clearly. I'll get to it. I'm not sure if something that he gets from, like, I can't really remember right now if it's something that he gets from game semantics, or if something that he's already like, that he already understands through the creation of linear logic, through the development of linear logic, that it's already a limit into how he wants to address the thing, right? Because all the time he's talking about, and I think that this is what he gets from game semantics, right? Like it's the strategy for proving X rather than if X is true or not, because these are independent things, so to say, right?
Okay, it seems like something like this, like, in traditional predicate logic, you are presupposing certain contents and certain forming a content, so to speak.
Yeah,
And the
exactly.
content, in a sense, is what makes true the form you are using. Like the contents are making the forms true, so to speak. Like the sky is blue.
Yeah.
You can't really derive the content from the form, something like that, right? But
exactly.
you can't really derive contents from forms. You will always have to, you know, apply this in a certain sense.
Yeah,
but
I think
the fact that he's kind of uncoupling, at least locally uncoupling the genesis of logical forms from truth and coupling to provability, in a sense, allows him to go deeper the genesis of these logical forms. This is, I think, very intuitively. I mean, what I take from. I'm not sure if I'm mistaken about this, but it's what I take from his approach up to a point. I think I'm not sure if I'm mistaken, but something like that.
Yeah,
and this is. Sorry, go on.
No, go ahead.
No, and this is kind of what happens in Rez's book as well, right? Like if you stick to inferentialism, you're always like, okay, applying labels to things, and these labels are constituted by the possible inferences because they're the things they are labeled, they are labeling the things, kind of, you are tracking the behavior of the thing, right? Something like that. So you're always in a sense, a Kantian form content dualism, whereas I think that ludics is trying to make something like Hegelianism for after Frege logic or something like that, you see, like to derive logical forms themselves, not to just see, not just to apply, you know, certain forms to the way contents manifest themselves. And this is very, very evident in the way Reza Nagastani uses this in Intelligence and Spirit, right? Because it provides us a kind of infrastructure, not so much, maybe not so much an infrastructure, but kind of lower level to what's going on in inferentialism. Like inferentialism is justified by the fact that the rules of interaction as such, with no consideration of contents, right, will kind of unfold in the direction of probability and sound inferences and all that. Like something like that. I'm not sure if I'm making myself clear.
Because I think that the interesting thing I think about what you're saying is that like it gives like some sort of like it gives definite structure to the process of linking like picturing and signifying, right? Like it gives, like if you can prove, like if you can make a proof, and this comes like later, I think, in something that I've been like really struggling with ludics, is like this sort of like whatever concept, but it's something that, you know, like that gives you like something is provable, or a feature of the provable things in ludics is that like it's it wins in terms of like it's a winning strategy in relation to every possible refutation, right? So like the idea of like connecting, like looking at, you know, looking above you and saying that it has a certain color, and other people agreeing with you all the time, except in the times that it's in a slightly different color. Like it has a structure already, like that any, like every concept, I like that's how I understand it or interpret it, is that like every concept, it's a proof of its own constitution, right? And that you have like this sort of...
That's incredibly compatible with inferentialism. That's quite incredible, right?
Yeah, exactly. But that's why I think, like, that's why I drank the Kool-Aid, is that like it seems like really compatible. That, you know, if you think about every concept being a proof, and I don't want to get like really ahead of myself without really doing the reading, but also it helps us think about the analytic synthetic distinction, right? Like because it like everything is a proof. It's just that like some proofs we already have the terms that we need to assert them, and others we don't. And the process of like constructing these new proofs of concept that allows us to like establish new proofs is what like whatever Kant or whoever said like call synthetic proofs, but it's just like it's like a time relation rather than like an intrinsic difference between these two different types of concepts. Just let me get something to drink and I'll keep going from game semantics.
Okay.
So I'll keep going, all right? Does anyone want to ask something else before we keep going?
I'm okay.
Cool. So this is kind of like, no, so now I'll just briefly, or not so briefly, introduce game semantics, which is, as I mentioned earlier, it's a certain, like a kind of precursor actually to linear logic. But I think that like the striking thing about ludics is the combination of, let's say, the development of linear logic and of game semantics or specific forms of game semantics. This is something that Girard talks a lot. Actually, he talks quite a bit, I think. I can't remember exactly in which of the papers he talks about already. He already kind of hints as game semantics being really important for the development of some of the ideas of linear logic. But yeah, so like game semantics comes from the sort of the intersection of the mathematical and the philosophical tradition in the 60s, which were different from the models of like proof theory and model theory. So like proof theory studies logical operators in terms of their roles within formal proof systems. So this gives us A proofs B. And model theory studies logical operators in terms of their correspondence with independent set theoretic constructions, focusing on the consequence relation between formulas given a semantic interpretation through these correspondences. So like A is a semantic correspondence of B. The contrast between these two relations is it's thought about as using it's what gives the definition of soundness. So A proves B only if A is a semantic consequence of B, and of completeness, which is the other way around. If A is a semantic consequence of B, then A proves B for deductive systems. So these game semantics is actually, like historically at least, two different things, although from what I understand, the bit of theological logic from Paul Lorenzen doesn't really get any traction. Like it's just something that he and his student do and then it dies out, but it's like depicted as being two different approaches. So like Paul Lorenzen develops this logic in relation to dialogic games, and Jaco Hintika works on the semantics of game theory. So Hintika combined the model theoretical, the epistemic, and the game-based traditions to develop what's like these days called explicit epistemic logic, where the epistemic content is introduced into the object language through an operator that has propositions from propositions, rather than in the form of this these meta constraints on the notion of inference. So in game semantics, and this is quite important, I think, for ludics. So the proof trees are written upside down, so that the initial assertion of a proponent stays above and it's defended against an opponent in a game. And the interactions between between the two players are represented as sequences, ordered sequences that form a tree. This is a kind of this is an approach to logic that's slightly more in concert with linguistics, which is more like a formal for which is a kind of idea of logic as being a model for argumentation rather than the derivation of truth, right? So the Lorenzen had this student, which is called Lorenz, or the other way around. It's very confusing. So his like first, like the proof of his system of dialogical logic is the demonstration of Gensen's consistency proof on a game theoretical framework. Both use the sort of like the notion of games, which kind of reintroduced like dialectical reasoning into the study of logic, right? Like, so they're both like really inspired by Wittgenstein and the idea of meaning as use. And the dialogical approach to logic is that the meaning of the logical constants is given by the norms or the rules of their use. So it's like explicitly Wittgensteinian. So this gives, like, this approach, it was sort of developed as providing an alternative to both model theoretic and proof theoretic semantics. So both approaches are based on the idea that like sentences or formulas, which are the syntax side, can be interpreted as propositions or semantics by identifying them with particular games. So these games are always governed by the same rules. They're asymmetric competition between two players. One is the defender attacker, or the proponent opponent, or me and the outside. The players always have the same moves available to them, like, which are like the challenges, which are the like, you know, the logical connectives as educating whether what one is asserting is true, is provable or not, let's say. And the game ends when one player loses, or when he like kind of exhausted all his choices for challenging the one, whatever it is that the other person tries to, or the other agent tries to assert. So so this gives like some sort of like good intuition for thinking about this, especially the like computer science application, as being not really about truth, which is, you know, not really predicated in the presence of any agents, but it's a kind of like process of verification between two parties, right? Like where you have like one asserts one thing and the other denies or disagrees. So this gives like a kind of a general model for interaction, which kind of brings us to Japaridze, which is, you know, oh yeah, I didn't remember that this was here. So Japaridze introduces, like, although he's not really, I think he comes much later. Like I'm do you know JP? Like I'm not like, I can't remember right now if he is someone that is like, he probably is not, although everyone's still alive. I think he's younger than the original proponents of game semantics. I think he comes like a little bit later onto the field. What?
I think Japaridze is alive.
Yeah, but all of them are actually, like, Hintika is also alive, no?
Yeah, Hintika is alive. Yeah. No, I think I'm not sure
Or-
about him. Maybe he died a few years back, but yeah. Not
Wait,
sure.
so Japaridze comes later, but I think his importance is that he's the one, as far as I know, that really
Yeah, Hintika
posits
died 5 years ago.
interaction as a what?
Hintika died 5 years ago. Yeah, I was.
Okay, you were right. But I think that Japaridze comes in as like both because he's a kind of reference for Reza, where I think I first encountered a lot of this stuff, but also because he gives his main thing is a theory of computation as interaction, right? Like he's not really a guy that's really concerned with like language or logic, but he's very much into like computation, explicit interactive approach based on the sort of insights that Hintika and Lorenzen gave us. So Japaridze recognizes in these developments a formal theory of interaction, which establishes interaction as computation. It says that the tasks that we normally use computers are interactive, where the system and the environment exchange information through observable actions, which he calls the interaction stories. And what he kind of gets out of this is that like any problem of computation can be understood as a pair of all possible interactions with a subset of all successful interaction stories, and the computer task is to ensure that the current interaction is among the successful ones. So this understands computational problems as dialogues or games between two agents, which are the machine and the environment. And from this perspective, like the environment is no longer a passive ambient space, but an active reactive element to which the system responds by accepting input from it and yielding output in which the environment consumes. In this setting, the rules of interaction emerge from the interaction itself. And I think that this also gives like a kind of a very good, like it's sort of like to go back to the idea like of what I was saying earlier about like how, like the Gabay, Woods, Magnani, Bardoni interpretation of like practical logic gives us a sense of like how expanding computational capacities gives us more access to computational resources that are found in the form of affordances in the environment, right? Like it gives like a very precise, not a very precise, I think that's stretching a little bit, like, but a somewhat precise intuition of like how this could be, right? Like of like how to like literally naturalize epistemology with a pragmatic orientation that it has like a computational structure or that it can be explained in computational terms. So to go back to Japaridze's theory, so on the input side, the system consumes, the system is the consumer, querying the environment for input it can use, and then the environment is the producer providing the output. On the output side, the roles are reversed. So what the system gives back to the agent uses as a new query to the system, and so on and so forth. So that's also like how it's related to linear logic and the idea of a resource logic, or in the sense that like you're always interactively rebuilding these questions or these searches, right? Like in the game, which is defined by this interaction, system and environment constantly switch roles to react one another, and what counts as a task for the system is an environmental resource, right? Like for the agent. So in this sense, the generality of interaction makes it like a really powerful way of bringing it together, the study of structures, informations, and behaviors. So like interactions describe the correspondence between computational behaviors, logical content, and mathematical structures, which is, you know, what we all like to call computational Trinitarianism, which kind of permeates a lot of the things that we talked about in the group, even though I don't think it usually shows up with this name. So like this is the thing. This is the thing that Girard uses to establish his sort of like the beginning of ludics, which is like moving from the meaning of logical rules is to be found in the preservation of truth to the meaning of logical rules is to be found in the rules themselves. So like for him, traditionally, syntax and semantics are completely inaccessible to one another, right? Like one is abstract and the other is infinite. Like I don't really know what he means with this because he's like a really difficult writer to parse. Like it's really difficult to understand what he means most of the time because of like how he writes, not because of the density of what he's saying. Some of the other interlocutors of ludics are a bit more, a bit easier, but this game interpretation gives like a very different idea of like what logic is, right? Like since proofs and reputations are represented by players, which are, you know, part of like nature, this makes us assume that this distinction between syntax and semantics is not something that it's like natural, but it's like a particular it's something that we're left with from a logic where completeness and soundness are really important. So like this isn't really a feature of the system, so to speak, but it's like a feature of a system that is not rich enough to capture all the system. I think that this is sort of like how he frames it, I guess. So if the question is meaning, and that's where he makes it really transcendental, because he thinks that meaning means meaning, not use or interpretation. And I think that this is the like how he moves from ludics, although like he talks about this in the inauguration of ludics. It's also what makes him move to transcendental syntax, because he can never get meaning out of the structure, but he thinks that you can get meaning out of the structure. And you can, if you subscribe to normativity rather than the sort of transcendental view, that you can get to the meaning of meaning. So his thesis is that you can use the meaning of logical rules is, we can find them in the geometrical structure of the rules themselves. So that negation is should not be interpreted as like not, but as an exchange between the player and opponent, and this opens a kind of different space in the study of logic, because it creates this sort of duality between proof and para-proof, or of challenge. So instead of getting getting a formal language that includes these formal rules, and we get formulas and theorems out of them, we interpret syntax in term like syntax is interpreted in the semantics with that and you sort of get a different interpretation of soundness and completeness, which are like theorems are interpreted by truths, and completeness, a formula whose interpretation is always a truth is a theorem, and this is sort of like how he gets structure out of ludics, even without appealing to this, like in terms of like what he means is not coming back to the idea of truth in opposition to provability, but that like if you take something that it's proved as a kind of truth of the system, you can sort of build a kind of a conceptual edifice with it without recurring to these sort of like external structures. So he says that like, and I'll get back to this once we get into the more like structural part of ludics. But he says that the answer is a universal game in which only certain kinds of strategies called designs are considered. Logic comes in when a player decides, in accordance with his opponent, to limit his designs, that is, to behave in a certain way. Logical formulas are therefore interpreted by behaviors, and a behavior being a set of design which is equal to its bi-orthogonal. And like figuring out what bi-orthogonal means was like a really big problem, which I only get in the end of this, right? So like what the difference in ludics is that it's not really, it doesn't come from the syntactic, it doesn't start with the syntactic elements of a logical system, like the formula syntax and the proof syntax. And then you find a game in these terms whose interactive structure has the right semantic fit. So like it doesn't matter if it's like classical logic, intuitionistic logic, or so on and so forth, but rather ludics tries to locate the interactive structure in the geometry of how syntax behaves inside the sequent calculus. So like in that sense, dialogues are games where what is at stake is a formula, and the set of rules is designed in such a way that the formula is valid in whatever way we can accept it. And and that the formula is valid in whatever way, in the way that we get, or valid in the sense of provable, if that player that defends this formula has a winning strategy in the game. So if he can make like the correct moves in saying that he whatever, I guess, but what he means, what he sees, or whatever structure we want to map onto this. So something that is really important for dialogical logic and the sort of move from model theoretic to proof theoretic is that like there's no infinity, there's no infinite quantifiers, there's no for all, and there's no exists, I think. So the sort of like dialogical notion, it's always based in the notion of game, and this is always like between someone that asserts something and the one who negates this assertion. So this is the structure that it presupposes, right? Like, so already with linear logic, Girard discovers this sort of the symmetry, like this connection between the symmetry of the classical and the linear sequence. So A is equivalent to not A, and the symmetry of negation in semantic games, right? Like, so attacking A is equivalent to defending not A. But he wants to sort of to really reassert the importance of interaction. So he has to sort of like get rid of like more features of like the traditional proofs, right? So this sort of so this is the two like radical, let's say, ideas of ludics are localization and counterproofs, which is like that. I'll get to this, but this is just the basic like structure of the like how it changes the sequence in ludics. So the positive is like the big wedge, the big end, and the positive is the she proofs big wedge, where where she, which is this E, the curly E. I'll just say curly E, which is better than she, because in English it doesn't make that the same. In Portuguese, it makes more sense to call it she, I guess. So where curly E is the locus, and big end is a finite set of sublocations, so to speak. So these two like new ideas in ludics, which are localization and counterproofs, are what suspend some of the like what he sees as limitations in game semantics. So normally, like in game semantics, every game starts with his own assertion, right? Like a proposition, it's directly connected to the game that starts with its own assertion. So localization suspends this by erasing the names of the proposition. So there's no like formulas like A, f of A and B for all x, f of x, etc., and only gives these sublocations, which are like curly E 0. So like it from moving from one side to the sequence to the other, you get like these sort of like sub connections. Like intuitively, I kind of think that this gives like a sense of which all of these like all of the like leaves in a proof tree are given by the initial proposition, and for something that it's contained there, like that's sort of like how I interpret this. So rather than like constantly appealing by things that are posited outside of the language, you only get the operations, right? And you have to construct it from, or you get the construction from these locations. Like this is something that it's still like a little bit difficult for me to grasp. So this is something that it's made by another by someone else working within linear logic, which is forgot his first name. I forgot his name actually, but that develops the method of focalization, which transforms linear proof trees into alternating sequences of positive, which are irreversible, and negative, which are reversible connective rules that move from the conclusion upwards. So Girard puts these two sequences together into application of a single positive or negative rule that makes it you change from one place to the other, which is the turnstile. So that's why you get from proofs curly to curly 0 proofs, and so on and so forth. So you get these exchanges between loci and subloci, from the specific locations inside ludics. So he suspends the distinction between the compound A and B and the atomic A and B formulas, and transforms them into locations curly E and sublocations curly 0 and curly 1, so that he can recover the behavior of the connectives of the connective end from this property of polarized tree. So the what comes from this cannot really be distinguished by what is asserted or concluded in them, and can only be indirectly associated with propositions by means of the interactive significance of defense and attack, and the geometric structure, right? Positive and negative. So like this is really stripping the entire thing to like really just the sort of like side to side move, right? Like and like in a strange way, like I'm not like a profound connoisseur of lambda calculus, but I think that it has like a really good, like a really interesting mapping to untyped lambda calculus, right? Like where you can there's only like one there's only one operation, which is cutting and paste, like which is, you know, equivalent to cutting and pasting, and this gives you like every program that can be rendered within the language. So the second thing of oh yeah, this is it, guys. Sorry, it's a lot of me talking now. So the second thing that that is suspended from game semantics is the, although there is a correspondence between proofs of a proposition and plays of a game, there are like many plays that not correspond to proofs, right? Like, so the losing strategies, right? Like when something is false and all the ways in which false can be found, or you can fail to prove something. And this is also like the interesting, I think one of the really interesting things, right? Like if he's really trying to get to the interactive dimension of proofs or of assertions or whatever, he also needs to give like a picture of not only proving things, but the ways in which proving fails, so that you have like not only a winning strategy, but all the losing strategies. And this becomes important towards like towards this idea of B orthogonality, or the way that I understand at least, like that this is actually the really important thing in order for B orthogonality to be possible. So ludics includes designs in his language that correspond to losing plays. So whatever, you know, like the things that logic usually doesn't really care about. So and he takes these designs as counterproofs by using the notion of cut, or let's say like taking a proof of not A and a proof of A proves B, or actually taking a proof of proves A and a proof of A proves B, and splicing like and deriving a proof of implies B. So you take two designs which are D and E with the same base Loki, which is curly E, but opposing polarity. So you have the positive, which is proves curly E as the proof assertion, and the negative curly E proves as refutation denial, and produces proofs of contradiction as a proof of, which is the empty sequent. So he gives, or like he, through this through this interpretation of cut elimination, he kind of produces the very structure that allows ludics to operate, right? Like he gives he sort of gives a proof of the structure of like what like he gives a proof of the difference between these two things, right? Of like asserting one and asserting the other. And this is like quite crucial, I think, to his whole endeavor. Is not that like the structure comes like already pre-made from like, you know, adopting a kind of formalism as the sequent calculus. Is that like he's able to, through manipulating these two symbols, right? Like he manages to give like a proof of the turnstile. This is at least how I understand it. So in any case, like the interaction of these opposing designs, so D and E, can be understood as the process of cut elimination, through which proofs that contain cuts are normalized into a proof that contains no cut. So this process works by pushing the initial cut at the root of the tree through its branches. So you put them together by sort of like composing the designs that interact. And I think that this is the sort of like the importance of the idea that you have the paraproofs, or I think he calls them in different, like I think the space, like he calls them tests, but the space in which the tests exist they exist as like the duality of proof is paraproof, I think, or of tests. I don't actually remember this right now, but he uses like a bunch of different terms to specify these things. But by accounting for these failed attempts, you can also extract up until where certain strategies work. So you get a sense of like salvaging partial structure, like from partial proofs, you can sort of build other proofs towards proving whatever it is that you want to prove. I kind of understand this as the sort of importance of this.
Can I just ask something? Could you go back just one slide? Sorry.
Yeah.
Is this the one? No, the one before, where you had the two kind of big ideas behind it, right? The counterproof and this sort of.
Yeah, exactly.
I mean, at that point there, it seems like, okay, my question is this, I'm not sure if it even makes sense. There is a connection between negation and, let's say, passing the move to the other agent, right?
Yeah.
But what is more primitive? The idea there are two agents, or this idea of negation? Like, because I get that this creates a sort of, I mean, I follow the very basic first intuition, like you have this big space of possible combinations, then you have this kind of trees of possible derivations, right?
Yeah.
And I got the idea that there is a specific definition of negation that is moving, that is, let's say, establishing, it's like it filters, yeah, exactly. The switch role operator.
Yeah.
That, but I'm trying to understand, like, why is where does it come, the necessity to think this in terms of roles and players? Like, I understand that it's kind of coded into game semantics that you move around agents or players or something like this, but in this idea of proof nets or something like that, it's not clear why that's, let's say, a necessary way of thinking about these steps. Like, I'm not sure.
Well, I think
as well on that topic, but go ahead, Pedro.
No, I just wanted to say that I think that the thing from here is that like he extracts negation from having two agents, right? Like that's the main thing. Like he structures like, let's say, the semantics of it by having, like, which is what it says here, right? Like that if you have two people and they're like, I guess the interactive structure is that, like, for one to, that is the sort of like the pre-given thing or whatever, is that like if like they must be like they must achieve agreement, they're not already in agreement, and that if one asserts one thing, then the other like automatically asserts the opposite, right? Because that's the dynamics that gives negation. gives like this sort of like immanent structure of having two things, or having like an opposition literally, gives the logic, like gives you negation without having to have a preconceived notion of negation, I guess. I guess that's the thing, right? Like you and that's where the switch operator things comes in, which is like to sort of oppose something, you have to prove that it's not true. You have to prove that it's false. And I think that this is the idea that, like, you know, that comes from linear logic, and that it's mapped onto this sort of different this sort of like different like language, even though it's sort of the same thing. But go ahead, Dennis.
Yeah, I was thinking about this in the context of the split between intuitionism and classical mathematics, where it seems like Girard is trying to basically take constructivism to its logical end in saying that, like, a proof should have, like, because the whole point of cut elimination is if A can prove B and B can prove C, then we can kind of throw away B if all we care about is C, right? I mean, we can get a proof from A to C directly, and we don't need B actually. And this actually opens up the space of, very similar to like programming, where you have different algorithms that can yield the kind of the same function, right? So if you think of
for sure.
Yeah, proofs are like machines that take some input assumptions and they produce an output statement, or in the Curry-Howard interpretation, it's like types are propositions. So you have a proposition like of a certain thing, and then or you want to prove a proposition like 1 + 1 = 2. So you make a program that it has that produces an element of type 1 + 1 = 2, and that is a proof. So this this idea of constructivism is now embodied in some kind of process, and this it seems like ludics is just trying to show that if you boil that down even further, it's just this, like, these empty spaces, I guess these loci, and this this interaction between these empty spaces is like a kind of a more stripped down version of computation of propositions, right?
Yeah, for sure. And I think
interaction of, you can think of it as two players, but it's just two kind of dual sides of the computation, where I don't know, it reminds me of Breuer. You know, Breuer, when he wrote the thing about intuitionism, he talks about like the tuity. And I was thinking, like, is this tuity kind of like the interaction that is happening in this thing, right? I can paste it here. Reading this is trying to understand.
No, for sure. I think one of the like footnotes from the, like, I really like a lot of the stuff that Girard writes is he likes to reverse the subtitle to Locus Solum, which is the paper that is the first paper that ludics appears, like, from the logic of rules to the rules of logic. And right in the beginning, he talks about intuitionism, and in that one of the, I don't know this, but I think that's what he says, that in the fundamental axiom of intuitionism, you derive a person that is present there as the thinking subject, right? And I think that this is like, I think that this is something that he takes as sort of like, and like, for sure, this is it really important for this inquiry into the idea of the meta like the meta language as the blind spot, because like in his sense, or if you accept some sort of like realism, it's like, okay, but where did this shit comes from? And I think that he uses the sort of like axiom of intuitionism as something that grounds the sort of like the game semantic interpretation of always having this opposition as being constitutive of a logic in itself. So I think that's pretty that's spot on. I think in a way, that's where it comes from. But already already in linear logic, he sort of understands that there's like a really nice triangle that it's on Zalamea's book, which is like on top is like classical logic, and then to the right there's intuitionistic logic and co-intuitionistic logic to the sides, and they both converge into linear logic.
Yes.
To sort of like give, right, like that gives like some sort of credence to the way in which it sort of can account for all of these different systems. But I think that the interesting thing, which I think it's where you're getting at, is that like this sort of like assumption of intuitionism is what grounds the idea of game semantics as being like a good foundations for logics.
Yeah, it's like with intuitionism, you get the tuity is the split between the, let's say, formal propositions and then the proofs, which are like the physical act of thinking that produces the proof, right? That produces that proposition or proves that proposition. So you have a split between a process and the thing that is being proved by the process. And then Girard is splitting that into two, showing that there's a duality within that process of which can be modeled as two players, one proving and one defending, right? Or one attacking, one defending.
Yeah.
But it's pretty crazy. I mean, it seems a bit arbitrary, right? I mean, like, what is to say that linear logic or ludics is not just one other model of logics? And like, I guess I don't understand enough to see how it encompasses other logics.
Well, I guess that's the thing, right? Like, I don't think, well, that's like a good question, but I also don't understand it enough. Like, I know that, like linear logic can model all of the other systems, but I don't know how this is like maybe like it's already given in the structure. It's just that I can't see it, like how you get like weakening and contraction from this. Right, but I think that the idea, I think what we give credence to the idea of this being a kind of like fundamental interactive structure, it's basically the idea that you can derive all of these rules from this like very simple interaction between these two things, right? Like between the assertion and the negation of it. Like, I would assume that like I don't think that he is. Well, I mean, maybe he is, but like the idea is not saying that this is the fundamental logic, because I think it's inscribed in some sort of like now I'm reading way into it, but I think it's really inscribed in some sort of like scientific realism, because he talks about in one of his texts, I think of normativity in logic, he talks a little bit about he talks about like there's no appeal to metaparticles anywhere in physics. Like, physics does really well without requiring a world outside of ours. So why would mathematics go through this route? that's sort of like the question that he asks, that I think it gives a lot of that it gives me the intuition that all of these developments are sort of being based in some sort of like loosely either scientific realism or some kind of naturalism. So I would say that like maybe the question is not that it's if it's the logic, because like, you know, in terms of like, now I'll shift more into like a Salarzian register, but like if everything, like if this is normative, like it just matters that, you know, like if this gives credence to the if this grounds normativity in some kind of interactive structure, it's enough. It doesn't really matter if it's D, right? Like, because assuming some sort of like, yeah, a kind of non-naive scientific realism would already like guarantee us that if it does the job that it does and it's much more basic, it already counts as a kind of basic description of it, right? Like a more fundamental, so to speak, even though I don't think, like maybe that's the thing, right? Like he's trying to get at like a even more fundamental view of logic, or where the rules of logic would come from. But I think because of these things, like I wouldn't think that he would say like, yeah, this is the thing that encapsulates everything because it's posited as such, but it's because it constructs everything from like even minor building blocks or something like that. And every, like the systems that are described around it, like normativity and like, you know, science and whatever, like give like good grounding to this position, I guess. But I think you're definitely right. Like if it doesn't, like he can't get to weakening and contraction from this, like he can't really prove that he has a logic in a weird way, right? Like if he can't substitute, like he cannot depict that how this structure, and I'm sure that he can. I would have to like this paper Locus Solum. It's really weird because it's written as a kind of glossary. So like nothing, like things aren't really in order. He just says what things are in alphabetical order almost. And you're like, yeah, okay, like I can't really put these things together because you're not telling me how to do it. But in other texts, he gives like a better explanation of this. But yeah, but I would think that if he can't recover like classical and intuitionistic logic from this, like he can't even start with his argument.
Mm-hmm. Yeah, I think yeah, we have to understand better the motivation here. I mean, I clearly see the benefit from your presentation of having this interaction, semantics, and kind of this way of grounding normativity in this interaction semantics. Yeah, I do see that benefit. Yeah, but I think for logic itself, it seems like, well, yeah, I mean, exactly this idea of being more computational, being able to model proofs in terms of finite resources, that does seem to have some advantage. Yeah, I don't know. It's definitely fun to think about.
Yeah, I think that's like a good point, because I don't think that like I think that this is actually really nice in thinking about more like Japaridzi's approach, because I don't think that this is like I think that this is trying to address a question which is quite important, I think, in theoretical computer science, which is like, what is computation? Because we use computation to sort of like mean a lot of different things when we think about like both computer science and otherwise. And I think that like Japaridzi's idea, I think, is to sort of like give I think geometry of interaction is a Girardian term, but to give like computation as interaction a more a model of computation that can be derived from very simple structures that are not dependent on that, you know, because I think that like the thing that like this opposition allows us to think, well, maybe it doesn't. And then lambda calculus would be like a better foundation for computation than interaction. But I think that it's like debatable, right? Like whether ludics could map onto because like type lambda calculus is it's normalizable in the same sense of linear logic. So maybe I don't know, but I think that the important bit about this is that it's giving like giving computation a clear definition, right? That it's grounded in structure, in some sort of like in some sort of like logical structure, right? Of like proving or like asserting and refuting, and that this would somehow like produce all the range of behaviors that we identify with computation. And I think that this is the thing that like, I think this is the thing that Reza really likes about Japarizzi. And that sort of like gives, like that sort of like brings together like the more Hegelian perspective with the computational dynamics perspective, I think.
Mm-hmm. Yeah, and in computation, we have the problem of like resource lock and of like concurrency and
yeah, exactly. Well, linear logic, it's really, I mean, that's what I understand is that it's like concurrency theory. It's based on linear logic. So I think that a lot of these developments have been I think not by Girard explicitly, but a lot of people that find use for linear logic come from this. And actually something that it has like a kind of funny overlap between what we've been talking in relation to the platform and stuff like that. There's a really nice startup called Statebox, which is, you know, all the cool category theorists are doing work with Petri nets, modeling like resources. And they use Petri nets as models for resource sensitivity in the blockchain for writing smart contracts. So there's like a kind of, I mean, you can sort of see how one would like, especially linear logic, not ludics, but maybe ludics as well. I don't know, would map onto these things in a much more applied way. So I also find this like sort of intriguing. Like how would you go from these like very basic ideas of interaction to much more complex ideas of resource sensitivity in systems? Cool. Should we keep going and try to finish up? There isn't like the idea of doing like a more precise technical ludics presentation will be sent further into the future, and we can definitely do it. I'll just need more time with it, and to sort of like bring in the categorical interpretation, or like how the categorical interpretation could give us some sort of like credence or some sort of like idea of like how to bring a lot of the stuff that we've been talking about together. So maybe we can keep going.
I think half of the folks have left. Maybe, and I don't have much time either. Maybe we can pause here and continue.
Yeah, for sure. At a later date.
Yeah.
Yeah, I'm about
No,
having to leave too.
Next
So
week, right? I think nobody's next week. I was going to do today, but I will need a couple of more weeks to read all the Gianotti I want to present. So you can maybe continue this next week if you want.
I'm not sure. I think nobody is next week. Nobody's scheduled.
Yeah, I don't know. I would think that I would need like way more time to really digest them, to do like something, because like at this point there isn't like much to go on. It's just like
Yeah,
finalizing.
I was actually browsing, Reza's chapter while you were talking, like